With support from PacTrans and the Oregon Department of Transportation, Oregon State University researchers have conducted 3 projects investigating the use of UAS in transportation. The first 2 projects investigated the use of UAS for bridge inspection. Using remotely piloted aircraft equipped for structural inspections, we acquired high-resolution imagery for 6 bridges in Oregon. Cracks, pack rust, connections, hardware, and bearing locations were all determined to be readily identifiable in the imagery, using the recommended data collection procedures. We found that UAS can assist to varying degrees in many required elements of an inspection, and are generally well suited for initial and routine inspections. Another key finding from our study was that 17% of the bridges that ODOT inspects annually might be good candidates for UAS. For example, in this image, the bridges shown in blue would be good candidates for use of UAS to aid in an inspection, while those shown in red would not. For the bridges shown in blue, if it's possible to reduce lane closures, traffic control, equipment rental, and total field time by using UAS, the total cost savings per year can be significant. The third research project investigated the use of UAS for traffic network monitoring. Due to the need for near real-time data, we chose to use LiDAR, or light detection and ranging technology, rather than just cameras on the remote aircraft in this project. This video clip shows a remote aircraft acquiring LiDAR data for a traffic intersection near the University of Washington campus, while a second remote aircraft is acquiring video imagery. Project partners at the University of Idaho investigated machine learning algorithms to automatically detect vehicles from the LiDAR data and imagery. This example shows LiDAR and imagery for an intersection near the Oregon State University campus. Based on the lessons learned from these research projects, we are currently planning a PacTrans UAS Research to Operations Tech Exchange. This workshop will be conducted in collaboration with ODOT. Topics will include operational aspects of building a state DOT UAS program, high accuracy position and navigation for surveying applications, and comparison of UAS-based LiDAR with structure for motion photogrammetry. A key focus will be on operational best practices for use of UAS in transportation.